Hey everyone! Today we're going to crack a code that turns confusing algebra into crystal clear pictures. We're talking about graphing lines. And believe it or not, our story starts in a very unexpected place.
And you know what? We're going to start right here with this super famous quote from a 17th century philosopher. It sounds really deep, maybe even a little mysterious.
So you're probably thinking, a philosopher? What in the world does he have to do with my math class? Well, as it turns out, pretty much everything. This is where the story of the graph really begins.
That story kicks off with a simple yet totally brilliant observation. And yeah, it involves a philosopher, a bedroom, and a fly.
So, the legend goes something like this. René Descartes is just lying in bed one day, watching a fly crawl around on the ceiling. And this question pops into his head. How could he describe exactly where that fly is at any single moment? And the solution he came up with? It was just brilliant. So simple. He realized he could just pick a corner of the ceiling as a fixed starting point. From there, he could measure the fly's distance along one wall, that's our x direction, and its distance along the other, the y direction. With just two numbers, he could pinpoint its location perfectly. And just like that, the Cartesian coordinate system was born, linking algebra and geometry forever. Okay, so Descartes and his fly gave us the grid, the playing field. But to actually draw a straight line on it, we need a set of instructions, a kind of secret code. And that code is famously known as y equals mx plus b. This little equation is called the slope-intercept form. And honestly, it's amazing because it packs everything you need to know into one tiny, neat little package. The m is the slope of the line, and the b is the y-intercept. Let's break that down right now. All right, let's start with b, the y-intercept. And hey, don't let that fancy name scare you off. All it means is begin here. Seriously, the b is just the spot where your line crosses that vertical y-axis. That's it. It's your starting point. Okay, now for m, the slope. If b is your starting point, think of m as your directions. It tells you exactly how to move to get to the next point on the line. We always talk about it as rise over run. Basically, how many steps up or down you take, and then how many steps left or right. And here's a great little trick to remember which is which. Just think. M and X go together like shoes and socks. They're always a pair. So the number that's literally attached to the X, that's always your slope. M. No exceptions. All right, we've got the code, we know what M and B are, so now let's put it all together into a simple two-step plan that'll let you turn any of these equations into a perfect line on a graph. It's super straightforward. Step 1, you've got to get your equation looking right. You need it in that y equals mx plus b format, which sometimes means you got to do a little algebra to get y all by itself. Then, step 2, begin with b. Just plot that y-intercept right on the axis. And then, move with m. Use your rise over run to find that second point. Boom, you're done. Yeah, sometimes you have to do a little tidying up first. You know, an equation like negative 4x plus 2y equals 8 isn't quite ready to go because that y isn't alone. But watch this. With a little bit of rearranging, we just add 4x to both sides, then divide everything by 2. It turns into y equals 2x plus 4. And look at that. Now our code is crystal clear. The slope m is 2, and the y-intercept b is 4. Okay, enough talk. Let's actually do one together. We're going to graph y equals 2x minus 1. Take a look at it. Before we even start, can you spot the starting point and the directions? Right, so we always start with b, our beginning point. In this equation, the b is negative 1. That's our y-intercept. So we just go to our graph, find negative 1 on that vertical y-axis, and put a dot right there. First step, done. Now we just follow the directions. And the directions come from our slope, m. Our m here is 2. Now to make that into rise over run, we can just think of it as a fraction, right? 2 over 1. So starting from that first dot we made at negative 1, we rise up 2 spaces, and then we run to the right 1 space. And right there, that's where our second dot goes. And here comes the best part, the really satisfying bit. You just take a ruler or anything straight and connect those 2 dots with a line. And that's it. Every single point on that line you just drew is a solution to that equation. We put some arrows on the ends to show it keeps going forever, and you've done it. You've just translated that algebra code into a real picture. Okay, so most lines you'll see are diagonal, slanting one way or another. But what about the weird ones? You know, the lines that are perfectly flat or perfectly straight up and down? Let's tackle these special cases so they never trip you up.
So check these out. A horizontal line is totally flat, right? It has zero rise. It's not going up or down at all. So its slope is just zero. Makes sense? But a vertical line, it's all rise with zero run. And since slope is rise divided by run, well, we can't divide by zero. That's a huge no-no in math. That's why we just say its slope is undefined.
But don't worry, there's an awesome little mnemonic to keep this all straight. Just remember this silly phrase. Hoi vux, Hoivux. Hoi reminds us that a horizontal line has a zero slope, and its equation looks like y equals some number. And vux, that's for vertical lines, which have an undefined slope, and their equations look like x equals a number. Seriously, this little trick is a total lifesaver.
So at this point, you might be thinking, okay, I can draw a line. So what? Who cares? Well, it's actually a huge deal. Because this skill isn't just about making pretty pictures, it's about finding answers. This is where it all pays off.
See, graphing is this incredibly powerful visual way to solve problems. Let's say you have two different equations, that's called a system. If you graph both of those lines on the same grid, you can literally see the solution. That one single point where they cross each other, that intersection, that is the one x and y value that works for both equations. It's like finding a hidden treasure map where x marks the spot. So, when it comes down to it, graphing a line is so much more than just connect the dots. It's about learning the language that connects algebra to geometry. It's how we take all those abstract x's and y's and turn them into a clear visual story that we can actually see and make sense of.
Think about it. From a simple fly buzzing on a ceiling all the way to finding the single solution for complex problems, every line really does tell a story. It maps out a relationship. So the only question left is, what story is your next line going to reveal?